Hey everybody, today we will do another video and it's going to be in the mathematics. It's going to be Laplace. Actually, it's going to be convolution, convolution, and Laplace, Laplace transform. Okay, so as we know that the Laplace transform has a definition, right? But I'm not going to go to the definition right now. What I will do is the convolution, but I will prove it with some of the properties that we have on the Laplace transform, right? So what the convolution says is that a function f, right? Notice that this is not multiplication, right? Making sure that this is not, don't take this as a multiplication. F g, right, equal to the integral of 0 to t, right, and f of tau t minus tau d tau, right? So basically what it is going to be tau is a dummy variable that we use, right? Like fake variable, right? Like fake news, right? So what we do is we're replacing, will we use tau to integrate this integral, and at the end we will replace, we will integrate with respect to t, and the t is going to be taken as a constant, right? So basically that's what we're doing. Now, so I will do one example of, let's say, for example, that f of t, right, is equal to 2t, right? And g of t is equal to 6t squared, right? Now, normally this guy we represent it as the easiest, right? At the easiest variable, but in this case, I will do this, and it's going to take a little while to do the math, but I will use the g instead of the f, right? So, and what happened is that the f of g, right? If we take a Laplace transform of f of g, which is like Laplace transform is like, not necessarily like that. It's kind of weird cheap. So Laplace transform of, right? Take Laplace transform of this guy, right? Of f and g, right? The Laplace transform of that is going to be equal to Laplace transform of can say that f of t, right, multiply by the Laplace transform of g of t, right? So in other words, the convolution of the two functions is the product of the two Laplace transforms, right? So we can prove that eventually, but we're not gonna do like the long way with the integrals and stuff like that on the Laplace transform. But we will actually do using the other properties that we have for Laplace transform. Okay, so let's get started on this. Let me write this up here. Okay, so f of t is equal to 2t, right? So f of t is equal to 2t, and g of t is equal to 6t squared, right? So that, and we find a Laplace transform of that, right? So then we can say that find the convolution, right? And prove it by Laplace transform. Right? So that's what we do, right? So, but I need some room, so I need to get rid of this. So just the problem statement. Okay. So first of all, we will use this guy. We will use this, right? So what I will do is I will say that I will make that my f, right? And remember, my f over here is the dummy variable already, the fake, like a fake variable, right? With respect to tau, it's I'm integrated with respect to tau. So what I will do is substitute and say, okay, so substitute from 0 to t, right? Now I'm taking this guy and I'm substituting this guy for 2, and I change the t to tau, right? And then inside this parenthesis, I will have this guy, but I will replace everywhere there is a t is going to be replaced by this guy, right? So let's do it. So in this case, it's going to be 6, right? And I would put the parenthesis inside the parenthesis, right? I will put t minus tau squared, and then I will put d tau, right? Okay, so now I need to work on this, right? So now what I will do is the following. So I will 0 to t, right? And I put 2 tau, right? 6. And I expand this. When I expand this, I get t, actually, I get t minus tau times t minus tau, right? And then when I do that, I get that from 0 to t, right? and I get 2 tau, right? And then I get 6 over here, right? And I get t squared, and I get minus t tau, right? And you can use lambda, you can use any data for this, right? So this is a t, this is a tau, right? I'm multiplying this times this, and then I do this times this, right? This times this is another t tau, right? And then this guy times this guy gave me positive, right? It gave me positive. Come on, right? Okay, so plus tau squared, right? Remember that I still have a little more to do, right? Because I need to distribute this 6 inside. So when I do that, right? I don't think I need this definition anymore. So get rid of that. I need some room. So okay, so now what I can do is bring this guy, right? So I will just keep going over here. So I will distribute the 6 inside, right? When I distribute the 6, and remember I still have d tau here. D tau, right? So over here I get the integral from 0 to t again, right? Now I have 2 tau right here, right? That guy, right? Now I got the 2 to the 6 across, inside, right? When I distribute the 6, I get, when I distribute that 6, right? It's going to be 6. It's going to be inside. It's going to be 6 t. So it's going to be 6, right? 6t squared, right? Inside, and then I need to add these 2 guys, right? I need to add these 2, right? So that becomes over here, if you can actually notice that these are negative, so this becomes negative 2 t tau, right? Negative 2 t tau, right? So those guys right here get, and this guy, and this 6, that 6 gets multiplied, right, by this 2, right here, this 2 t tau, right? And I get the following, I get the following, I get 12 tau, I will just reverse that tau and put it over here, tau t, right? And again, it's kind of rough to keep, I mean, I know what I'm doing, but probably this might create confusion because the tau look like teeth, but, I usually make my tau like that. Okay. So now I multiply that 6 right there times that tau squared, and that gave me plus 6 tau squared. Right. So now I got this done, and I still have my dt here, my d tau, right? Now I still have to do more, right? This guy has to be distributed inside. So right here, I distribute this, right? And it becomes from 0 to t, right? The integral from 0 to t. And then that 2 tau gets inside, right? So when I distribute that 2 tau inside, I get what? I get 12. I get 12 tau t squared, right? Then this one is going to be minus, 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 minus 24 tau squared t, right? Then this guy and this guy right here is plus 12 tau cubed, right? And then everything is integrated. It's being integrated with respect to tau. Now, the last step is going to be to integrate with respect to tau, right? Honestly, not the last step at the moment, right? It's going to be another step after this. But when I integrate this, right, I'm going to integrate with respect to tau. So this guy right here, let's see. Yes. So this guy right here becomes what? Becomes 12, right? 12 tau squared t squared, right? And I am dividing by that, right? By the exponent, right? Divided by the exponent that is being created with the integration, right? Minus, and I hope you would remember integration because I am not, I'm saying I am just doing this, right? So, so I am, like I say, this is already integrated, right? Need to be simplified though, but just integration is fine as it is. Now, so right here, this 24 t tau, right? 24 t tau squared t. Yeah. So now this I am integrated with respect to this tau, so it's going to be 24 tau cubed, right? And divided by 3, right? Divided by the new exponent again. So now this guy right here plus the integral of this is going to be 12 tau to the fourth divided by 4, right? Okay, so now we can do some simplification, right? So now this can be divided by, right, by 6, right? This guy can be divided right here into 8, right? And of course it's negative, right? Just make sure that we get the negative, right? And remember that in this guy was carrying a t, so this t right here need to be this t, right? So now this guy right here can be 1 and it can be crossed by 3, right? So now that I have this, right? Now I can rewrite this right here and I can say that 6, right? 6 tau squared t squared, right? Minus the 8, right? T cubed times t minus 8. I'm sorry, tau cubed, right? Did I say t? Right? Tau cubed times t, tau cubed t, right? Plus this guy. So now I have 3 tau to the fourth, right? Now I am integrating that from 0 to t, right? So integrating from 0 to t, right? Now let me erase some of that stuff over here because I need this room, right? I need room. So let me erase this. So now Now notice that I have 6 tau, 6 tau squared t squared, right? Minus 8 tau cubed t, just t, right? Plus 3t to the fourth. Now I am integrating that again from 0 to t, right? So I am replacing, because I integrated with respect to tau, whatever is a tau, anywhere there's a tau, I have to replace it with a t, right? So now I have this t, I have this tau squared, so it's going to be 6, right? So now it's going to be this, instead of being a tau, I am replacing, right, the fake news, right, with the real, right, with nukemax, right? I am replacing fake news with newsmax. Okay, so now right here I am replacing that, right? So it's going to be t, right, squared times t squared, right, minus 8, right? This is a tau, so it's going to be t cubed, right, times t, right? Now plus 3t, right? This is a tau, so 3t to the fourth, right? Now, this is when I replace tau, right? When I put 0 for every single tau, well, that is 0, right? Everything goes to 0, right? 0, 0, and 0. Everything goes to 0, right? So now that is technically, the integration. Now what I can do is just simplify the exponent, and those exponent and this, right? And those, and then add those. So I get 6t to the fourth, right? Adding those two exponents minus 8. 1 exponent plus 3 is going to be t, to the fourth, right? Plus 3t to the fourth, right? So now notice that this can be added together, right? So it's going to be 9t to the fourth minus 8 to the fourth, which is equal to t to the fourth. And this whole, a lot of work for just to get that t to the fourth. And it looked like a tau. Actually, it's very, it's very confusing, but it is what it is, right? So, I mean, it's not confusing for me. It's just, I know what I'm doing. It's just you write a tau and look like a T sometimes. Okay, so now this is this, right? Now, what did we say, right? So we found out that guy is the convolution, right? That is the convolution, right? So this guy is the convolution. Right. Now, we need to verify that is equal to the Laplace transform of the two individual ones. Okay. So first we will take just the Laplace transform of this. Right. So the Laplace transform, right? Laplace transform of this, of t to the fourth, right? The Laplace transform of this, and matter of fact, this is not the right symbol, but I'm sorry, I'm not going to try to figure out what is the right symbol for the Laplace transform at the moment. Don't care. As long as the mathematics can be correctly, that's it. That's all I care about it. Okay, so this is, okay, so I gotta take the Laplace transform of that, right? So what if the Laplace transform says? Take the n power, right? Take that n power, right? The n power is called n factorial, right? So that is in the form of t to the n, right? And I'm taking the n power and I'm replacing and I put an n factorial, put the factorial in there. And then in the bottom, what I'm going to do, I'm going to put s, right? The exponent that I initially have, right? What is the exponent? It's 4. 4 plus 1, right? 4 plus 1. It's like 4 plus 1. Like, like the limit plus 1? Or maybe the passing square plus 1, right? I guess you're happy with 61. You get a D, right? It's 60 plus 1. 1 point extra, 61, right? Okay, so plus 1 at the bottom, right? Actually, I guess the D for done is good. I mean, if you want to get, I'm not saying, right? You can get a D in literature, in poetry. You become an engineer, yeah. I mean, if you want to get a D for done in literature, American literature, or some poetry, or maybe some philosophy courses that you don't need actually mathematics or or sciences, just take a D for done, right? Just right. Just okay. So, but anyway, but I'm not saying that it's up to you, right? I'm not trying to encourage you to get a D, right? Okay, so now what we're doing right here is the following. So we do T, right? Actually, no, it's we do the factorial, right? So we do 4 factorial, and the 4 factorial is 4 times 3 times 2 times 1, right? Okay, right? So this is 12 times 2 is 24, and times 1 is, I would say, 24, right? So now, right here, I get an S in the bottom. S, 4 plus 1 is 5 after the fifth, which is equal to what? It's equal to 12, 24, 24. 24 over what? Over S to the fifth. That is Laplace transform of this guy. Okay, so now to prove it, I will have to take the Laplace transform of each individual one and see if the product is going to be equal to this. And this look at like an S, but make 5. Right. So now let's do this. Right. Now let me take Laplace transform of each individually. Right. So in Laplace transform of this, it's going to be right. So right here, you have a 2, right? So Laplace transform of f of t, right? So now of f of t is equal to the Laplace transform is going to be equal to whatever is inside, right? But remember that I have a coefficient in front of it, so that is going to be 2, right? And then Laplace transform of what? Laplace transform of t inside, right? And this usually we try to do some curly brackets. right? So right here, okay, so I have a t, right? That t is to the power of 1. So t is to the power of 1, right? So what it is going to be, so it's going to be t, right? Inside it. Now notice that t is to the power of 1. So what I will do is the following. So I will take that t and put it like this, right? Just put a 2, right? This the 2, right? This 2 right here comes over here, right? And I get the following. So I am doing that is going to be the power of 1, right? So what is the power of this? It's 1. So 1 factorial, right? Over, right? Remember, this is the power of 1 right here. So it's s to the power of 1 plus 1. So which is technically is 2 over what? 2 is 2 over s squared, right? That is for this guy. That's the Laplace transform for that guy. Now let me do the Laplace transform for this guy. So this guy is the following. So this guy, the Laplace transform for this is going to be what? It's going to be 6, right? It's going to be 6. It's going to be 6, right? And inside is going to be a t, right? It's going to be a t squared, right? Now, inside this t, well, I got a t, right? I taking the Laplace transform of that, which is going to be 6, right? And then Laplace transform of this. Laplace transform of this guy is going to be what? It's going to be the following. So it is going to be the following. So now this is going to be like this. So the 2, right? 2 factorial, 2 times 1 on top, right? And then the bottom is going to have s, right? S squared plus 1, right? So s squared plus 1, right? So now when I take the Laplace transform of that, it's going to be this guy is going to be 12, right? So it's going to be 6 times 6 times 2, right? 6 times 2, right? Right? 2 factorial is 2 over s cubed. See that? Now this is nothing but 12s cubed, right? Now let's prove it. So now this guy times this guy, how much we get, right? That's the good question. Okay, so let's multiply those two Laplace transform together. So Laplace transform, right? So Laplace transform of 2t multiplying the product, right? The Laplace transform of 6 t squared, right? So we proven this, right? So what we get? So we get what? We get 12 over s cubed, right? Times 2 times let's put a dot in here, multiplying, right? Times 2 over s squared, right? And what do we get? When you add this exponent right here, this s cubed and that x squared, and then the exponent is s to the fifth, right? Like bases, right? Base and base is the same, and the exponents are different, but you can add them. So that is going to be equal to 24 over s to the fifth. S to the fifth. And that is exactly what we got it when we did the regular, right? So when we did the convolution, right? In other words, when we took the Laplace transform of the convolution, we got the same thing as taking each individual Laplace transform of each function, right? And when we did that, it becomes the same thing, right? See? 24x to the fifth, 24 over x to the fifth, 24 over x to the fifth, right? And the convolution is equal to that, right? So that's the beauty of mathematics, that when you taste in it and you're doing the right thing, it doesn't matter you cannot write the symbol, right, of the Laplace transform. That doesn't really matter, right? This is what matters. See how you can prove that the convolution, the Laplace transform of the convolution is equal to the Laplace transform of each individual two function. Thank you for watching, and I see you in the next video.